Hello, everyone. My name is Maureen, and as the president of the Nanotechnology World Association and sponsor of the NanoScientific Symposium, I would like to welcome all of you connected with us today. 2020 has been a challenging year for many of us, but it was also a catalyst to make us realize that we can work together despite the distance, and that the power of today's technology made a tremendous difference on how we handle that global crisis. Understanding the relation between humans and technology is key to responsible development and acceptance of future technologies in almost every application field, be it energy, mobility, health, work, living, learning, entertainment, etc. We need to understand better how past technologies have deeply changed human existence and how future technologies may impact us as human beings and our society. This reflection will help to design technologies with maximal values and minimal frictions in a responsible way. But how can we connect the world of academic research and real-life applications? How to make sure that the amazing discoveries that are made every day in labs around the world and that are truly have the potential to have serious impact on today's world can successfully be transferred from lab to market. This is exactly the reason why the Nanotechnology World Association was created. Our mission is to globally promote nanotechnology solutions adoption across industries by connecting entrepreneurs with scientists and startups with investors. Before we dive into the issues of nanotechnology tech transfer and the strategies to overcome them, allow me to share a quick overview of who we are and what we do. NWA was created in 2011. At first, it was just an information blog, keeping geeks like me up to date with the latest discoveries in physics, and more precisely in the field of nanotechnology. Fast forward a few years, and we had a fast-growing network of over 100,000 followers with a common need to be connected to each other. Our network is a mix of people from academic, industrial, and financial worlds, geographically spread around the globe. After several discussions with close contacts from the network, we agreed that the time was right to officially launch the association with the help of 11 founding members, all from the nanotech industries. The Nanotechnology World Association was officially launched in October 2019. We can also count on the help of and support of the board of directors and the board of advisors, deeply involved in various segments of the value chain. Coming from academic and industrial worlds, these experts are helping the association create the necessary tools and solutions to facilitate the nanotechnology tech transfer. Over the next 5 years, we will launch several services for our members, such as cross-sectors, networking events, annual conferences, workshops, work groups, etc. The COVID crisis forced us to postpone most activities, but we are ready to resume all events as soon as the world opens for our business again, hopefully in January. So our services and activities are specifically designed to enable, support, and facilitate the nanotechnology transfer from lab to market. On a daily basis, we connect people. We keep our network up to date with science articles. We organize and centralize information, and we help commercialize new technologies by bringing together the right individual around the table. Our platform is also designed to allow members to create their own local activities, and we are planning on creating local chapters in the upcoming months. Now that you know a little bit more about us, let's get into the topic of today's discussion about the challenges that the commercialization of nanotechnology represent and the solution that would greatly help the process. Having a great technology is a necessary start, of course, but how do you get from there to having a successful product? There are many reasons why nanotechnology technology startup fail. The number one reason is irrelevance, no market needed. A recent study on over 100 startups' failure highlighted the lack of market need. That the lack of market need was a factor of 42% of failures. 42%. See, this is really a huge number. Also, you can have a good tech that fits a market need, but a team with no entrepreneurship skills, it will fail. If you have a good tech, a market need, and entrepreneurship, but lack the funding, it will fail. So to create a successful product, we need all of these four ingredients. Currently, this is the process that tech goes through to become a market product. On the academic side, you have researchers who don't know the market, who aren't really interested in business, or who may have all sorts of different personalities and skills. On the other side, there are industrials who have very specific needs to enhance the quality of their products. And although they might have heard about nanotechnology and how it can help them, they don't really know how it can be done. They don't really know what's available and how they can benefit from it. This leaves a gap at a crucial time in this process, right when the technologies are mature enough to leave the universities and go out to the market. Yet this is the moment when we are the least equipped to deal with this. There is a lack of communication, information, connections between these two worlds, which prevents a large number of technologies from hitting the market. Of course, most universities do have tech transfer offices that understand the process which you need to go through to move forward and potentially patent and commercialize any aspect of your work. They support researchers from an administrative and legal angle, helping them licensing, funding, connections. But as many researchers told us, the process is long, complicated, and very administrative. Furthermore, they are not nanotechnology specialists, but rather generalists, having to support a broad range of disciplines. So at this point, and on a global scale, the connection between academy and industry is not optimal. To create a bridge to optimize this whole scientific, technical, and commercial ecosystem, there are many options to ensure that nanotechnology make its way from the lab to the end users and succeed in improving the life for all of us. We need our scientists to have freedom to explore with fundamental research, but we also need part of the academic world discoveries to be commercialized to help solve the issues we face as a society. The goal is to maximize the role of our universities in contributing in the optimization of the use of their research and the impact on our future without removing their freedom of research. If you look around at the biggest startups that we all know about, all these people are incredibly creative thinkers. They think outside the box. And my feeling is that sometimes in academia, they don't necessarily pay much attention or acknowledge or even reward that kind of way of thinking. specifically when we talk about commercializing, or potentially creating a startup company from an area of research. The required creative thinking to reach commercial success is not necessarily encouraged on the academic side. It's not rewarded from an academic point of view. We also need to create more dialogue between academic researchers and industrial tech teams so that they can learn to understand each other, their needs, and their realities. In order for scientists to identify business opportunities and generate ideas related to their research, having direct inputs from a commercial point of view would seriously help the process. Generally, researchers don't have time to make a proof of concept when they want to validate that a discovery has a potential. They need some sort of commercial validation before investing time toward a potential product. On the other hand, most industrials and investors will require a proof of concept as a first step of the exploration phase. On the academic side, it would be useful to translate their technology, their research, into commercially understandable material for industrial, so that the tech people from the industry understand more easily how they could beneficiate from that new tech and how they could incorporate it into their product. Regarding the gap between what comes out from the lab and what is needed from the industry, we could also imagine the creation of specific PhD programs funded by the industry partners, focusing on technologies needed for their products' enhancement and allowing researchers to work on that research within their academic reality. On the industrial side, the creation of startup accelerators, business incubators are paramount. We need to incorporate academic researchers into the industrial R&D process. We need to create the links through events, work group, information sessions, etc. To summarize, a scientist with business knowledge and understanding of the industrial reality are rare. The skills needed to be a successful tech entrepreneur are not the same skills as that makes a good scientist, and vice versa. So mentorship from business-oriented scientists who are also comfortable with the process, cross-sector activities, academy, industry networking events, hands-on training, support services, work groups, case studies, etc., are necessary to educate and build confidence in the researchers, since most of them think it's not for me, I don't know much about that world, commercialization is not really the reason I went into this, etc. We also need to work on the way we do things in university. For example, when in the process of licensing a technology for researchers, in licensing technology, researchers cannot publish anything related to that work during the entire period of the patenting process, which can last sometimes a few years. Is it worth it for researchers to do so? So mentors and case studies are gold. It's easier to learn from people who went through the exact same challenges and understand the academic reality. In conclusion, scientific research is the pursuit of knowledge. It isn't bothered by market relevance or irrelevance. Some scientific discoveries are relevant to the market, some are not. Relevance requires complicit cooperation between science, industry, and funding. To bring science closer to market, industry, and funding, all these spheres must come together, must work together. It's all about education, collaboration, meeting the right people, and that was the initial reason why the association was created, to connect, to inform, to organize, and to commercialize. Thank you very much for your attention.